Okay, welcome everyone to a new deep dive.
Hi there.
We've got some really interesting source material in front of us today. It's this guide called Quinta Essentia, a practical guide to space-time engineering part 2, Electrogravimagnetics, EGM for short.
Yeah, that title alone, it tells you quite a bit, doesn't it? Sounds fundamental, but also like practical, engineering even.
Absolutely. And that's really our mission today, to unpack what's going on here. The authors are introducing this new mathematical method, EGM.
Right. And it offers a different way of looking at gravity, space-time, the really basic stuff in physics.
So we want to help you understand the main ideas, where they're coming from historically, and honestly, some pretty ambitious claims they make about this method.
And they don't frame it as just, abstract theory. They call it an engineering tool, a method.
Uh-huh. They argue it gives astonishing results, backed by verified calculations. It's really positioned as an alternative way to see nature, specifically through an electromagnetic lens.
Okay, so let's get into it. The guide kicks off with a huge question, one people have wrestled with for, well, forever.
What is space? Is it just empty? A void? Or is there something in it? An ether?
Takes us right back to the ancient Greeks, doesn't it? Empedocles, his four elements. Lucretius saying, nothing comes from nothing.
Which, as the source points out, kind of echoes modern conservation of energy, right? Things don't just pop into existence.
Exactly. There's continuity.
Then you have the atomists, Leucippus, Democritus. For their idea of atoms to work, they needed empty space. A void.
Right. How else would the atoms move around and bump into each other? No void, no atomic universe.
The Pythagoreans also thought the void was needed, but more to keep things separate, distinct.
But Aristotle wasn't having it. Nature abhors a vacuum, he said. He thought stuff would always rush in to fill any gap. Space couldn't really be empty.
And this line of thinking leads us to Plato. He took the idea of elements further, adding a fifth one.
The quintessentia, the fifth essence, which became basically synonymous with the ether.
Plato linked it to the dodecahedron shape, saw it as this eternal, unchanging cosmic fabric.
In the source notes, something really fascinating here, kind of parallel. Plato's idea of basic shapes, maybe breaking down into triangles, has this weird resonance with modern quark triplets making up protons and neutrons.
Like a conceptual echo, thousands of years later.
Right.
Wild.
So fast forward quite a bit to the age of mechanics, Newton.
Right. Gravity.
Mm-hmm.
A force acting instantly across huge distances. Action at a distance.
Newton himself was a bit bothered by that. How does it get there? He thought about an ether, but realized if it was like a fluid, it should slow the planets down. But they don't slow down.
Yeah, he wrote in Optics about needing something in those almost empty places for gravity to work between the sun and planets, but he didn't want to just guess what it was.
He famously said he wouldn't feign hypotheses. Describe the effects. Don't invent unseen causes.
Then came James Clerk Maxwell, huge step. Unified electricity and magnetism. Showed light was an electromagnetic wave.
And that brought the ether idea roaring back. Specifically, the luminiferous ether, the stuff light waves supposedly travel through.
The Victorians loved mechanistic explanations, didn't they? They imagined space filled with, like, invisible cogs and wheels transmitting light, maybe gravity too, trying to solve Newton's action at a distance problem.
Which set the stage for that crucial experiment, Michelson-Morley, 1887.
They were trying to detect the Earth moving through this luminiferous ether, looking for interference patterns in light waves, like in Young's double-slit experiment.
If the ether existed as this background medium, moving through it should affect the light speed, create fringes.
Nothing. No interference pattern. No sign of moving relative to some fixed ether.
And the source says this result basically silenced the debate on that kind of mechanical, fluid-like ether, the kind that would cause drag.
But importantly, the source emphasizes that this didn't kill the idea of an ether altogether, just that specific mechanical version. A different concept could still emerge.
Which leads us straight to Einstein, general relativity, GR.
GR throws out the mechanical ether and gives us curved space-time. Gravity isn't a force pulling things, it's the geometry of space-time itself being warped by mass and energy.
Objects just follow the straightest possible paths geodesics through this curved landscape.
Now, the source we're looking at is pretty blunt about this. It calls space-time curvature, a physically meaningless term.
Ouch. Yeah, they see it as a mathematical trick, basically. A way to describe that gravity happens, but not why space behaves that way or what's physically going on.
Though it's interesting, even Einstein seemed to feel space needed some properties. He said in 1920, space without ether is unthinkable in the context of GR. Maybe not mechanical, but something.
Right. GR needs a medium that can be curved, that can have geometric properties.
And GR rests on the equivalence principle. Gravity and inertia are essentially the same thing.
Which ties into EMC2. That famous equation comes from thinking about inertia. The energy needed to change motion is linked to mass. Mass is energy.
So GR was revolutionary, gave us this geometric picture, but maybe left the door open on the physical nature of space and what inertia really is.
And that's where quantum mechanics comes into the picture, offering a totally different view.
Instead of GR's curved emptiness, QM talks about the quantum vacuum, the QV, or the zero-point field, ZPF.
And this vacuum is anything but empty. It's described as this effervescent matrix of energy, constantly fluctuating. Think of it as buzzing with virtual particles popping in and out of existence.
So light in this picture isn't just a wave in nothing. It's maybe a fluctuation in this energetic field.
That's one way to look at it. And there's actual physical evidence for this quantum vacuum energy, or QVE.
The Casimir effect, right?
Exactly. Predicted by Henry Casimir, you take two neutral metal plates, put them incredibly close together in a vacuum.
And they attract each other.
Right. Why? Because the plates restrict the kinds of QV energy fluctuations, the wavelengths that can fit between them.
So there are more possible fluctuations, more energy modes outside the plates than between them.
Precisely. The source explains it as more QVE pressure pushing from the outside than the inside, squeezing the plates together.
A force from empty space. That's kind of mind-bending.
The source even mentions this cool nautical analogy. Apparently, back in the day, sailors noticed big ships floating close together in calm seas would sometimes drift towards each other.
Really? How's that related?
Same principle, basically. Sipko Berersma highlighted this. The ships act like boundaries for the water waves, just like the plates do for QV waves. Fewer wave modes between them, more pressure from the outside.
That makes it much more intuitive. A real-world parallel.
And importantly, the Casimir effect isn't just theory, it's been measured. Lemereau did it in 97, Mohideen and Roy in 98. It's real.
Okay, so the quantum vacuum is real and energetic. How does this connect back to, say, inertia, that puzzle of why things resist being pushed?
Well, there was Mach's principle, which the source mentions. Ernst Mach thought inertia might be caused by the gravitational pull of everything else in the universe, like you're moving relative to all the distant stars.
But that idea had problems, didn't it? Like, it should cause drag even if you're moving steadily, not just when accelerating. And we don't feel that.
Right. Inertia is about resistance to acceleration.
So this is where the quantum vacuum inertia hypothesis comes in. QVIH, Heisch, and Verweyde.
Exactly. They looked at the QV again, but thought about radiation pressure. What if inertia is an electromagnetic effect from the vacuum itself?
How would that work?
They proposed that when you accelerate through the quantum vacuum, it looks different. It becomes asymmetric from your point of view.
Okay.
This asymmetry creates a net electromagnetic force, a kind of drag pushing back against your acceleration, a net pointing vector, technically. And crucially, this drag force turns out to be directly proportional to the acceleration.
Which is the definition of inertia.
Precisely.
Why only during acceleration? Why not constant velocity?
That's the clever bit. The QV isn't uniform across all frequencies. It has a cubic frequency distribution, much more energy packed into higher frequencies, shorter wavelengths. When you move at a constant speed, the Doppler effect shifts these frequencies. But because of that cubic distribution, the blue-shifted high-frequency photons perfectly balance out the red-shifted ones. The vacuum still looks symmetric overall.
But acceleration breaks that symmetry.
Right. Acceleration messes up that perfect balance, creates the asymmetry, and that's when you feel the drag force inertia.
That's a really different way to think about it. And they connect this back to GR.
They do. They argue that QVIH's symmetric vacuum, uniform motion, corresponds to GR's flat spacetime. And QVIH's asymmetric vacuum, acceleration, or near a mass, corresponds to GR's curved spacetime.
So replacing geometry with vacuum energy distributions.
Yeah, the source suggests QVIH uses more intuitive, physically grounded terms, symmetrical or asymmetrical QVE distributions, instead of GR's more abstract, metaphysical, non-intuitive terminology like curvature.
It's trying to provide a physical mechanism for effects GR just describes geometrically.
Which leads nicely into another related idea mentioned, the polarizable vacuum approach to GRPV Harold Puthoff's work, building on others.
Polarizable, like the vacuum itself can be electrically distorted.
Sort of. It's more like an optical analogy. Think of space-time itself having a refractive index, like glass or water.
So space acts like a lens.
That's the core idea. Instead of geometric curvature, the PV model says spacetime has a variable refractive index, KPV they call it. And this index depends on the local energy density of the vacuum,
Ah, so mass affects the vacuum energy density nearby,
which changes the vacuum's refractive index.
which then bends the paths of light and matter passing through, like a lens bends light.
Exactly. Instead of matter tells space how to curve, it's more like matter changes the vacuum's optical properties, and those properties guide motion. The vacuum is the gravitational lens.
Okay, this is fascinating groundwork. Which brings us finally to the main subject of the guide, electrogravimagnetics, EGM.
Right. After all that background, EGM is presented as the way to actually calculate things using this polarizable vacuum idea.
So it's the mathematical method, the engineering tool they mentioned at the start.
Yeah, it's designed to take this physical picture space as a refractive medium influenced by electromagnetism and turn it into numbers, predictions, something you can work with.
And the core premise, just to restate it,
Gravity isn't fundamental in the usual sense. It's a side effect, an outcome of electromagnetic interactions between matter and the surrounding vacuum energy,
these interactions create gradients, like differing densities in the vacuum energy.
making spacetime refractive, changing its optical properties locally. That's what we perceive as gravity, not geometry, but refraction.
So the difference from GR, as they see it, is EGM explains why space becomes refractive, while GR just describes that it appears curved. Mechanism versus description.
That seems to be their argument, and they make some really, really big claims about what this EGM method can achieve.
You mentioned astonishing results, highly accurate calculations.
Yeah, they state it reveals a universal principle working from subatomic particles all the way up to the cosmos.
Okay, let's look at some specifics they claim referencing that list in the guide. Particle physics.
They claim EGM calculations give precise values for things like the proton and neutron radius. They even talk about predicting new particles, leptons and bosons.
And they say these calculations match up with experimental data?
They mention comparing their results to data from big physics collaborations, PDG, ZUS, SNO, D0. They also claim to derive fundamental constants, like the fine structure constant, and explain the Casimir force using EGM.
Wow. Okay, what about cosmology? The big picture.
They claim derivations for the current age, size, mass, density of the universe, the history of the Hubble constant, the cosmic microwave background temperature.
Seriously, driving those values from this EM vacuum interaction model.
That's the claim. Plus insights into dark matter and dark energy, and even deriving properties of black holes, minimum mass, radius, that sort of thing.
And it doesn't stop there.
No, they also mention deriving fundamental scales like the Planck scale, the Bohr radius for atoms, the hydrogen spectrum, basically touching on foundational aspects across physics.
And the bottom line is they say these calculated results match physical measurements very closely.
They state key predictions are considered exact within experimental uncertainty. That's a very strong claim.
Incredibly bold claims covering almost all of modern physics. How does the guide itself back this up? Does it show the math, the derivations?
It seems the guide focuses on presenting the EGM methods and showing how they apply them to get these results. It's more about demonstrating the supposed power and consistency of their mathematical framework to reproduce known physics from their different starting point, less about providing independent external validation within this specific document.
Got it. So it's laying out the how-to and showing, look what we argue it can do.
Right. And the authors explicitly state their hope. They want people to learn EGM, use it, or maybe develop similar ideas.
For a very specific, almost sci-fi sounding purpose.
Yeah. Technological progress in gravity control or superluminal travel, faster than light travel.
They're directly linking this fundamental physics model to possibilities like controlling gravity, maybe even warp drive, by manipulating these EM vacuum interactions.
If space is like a refractive medium you can interact with electromagnetically, well, maybe you can engineer it. That seems to be the implication.
Okay, so stepping back, what does this all mean for you, listening right now? Why should you care about this EGM stuff?
Well, fundamentally, this source is proposing a radically different way to understand the universe compared to the standard models.
It's trying to connect the big, general relativity, gravity, and the small, quantum mechanics, with a single underlying physical picture.
Right. Replacing abstract geometry with a physical electromagnetic process involving the vacuum energy.
It argues space isn't passive. It's an active, energetic medium. Its properties, like how it bends light or affects motion, come from EM interactions with matter.
And the authors claim EGM is the mathematical key to unlocking this. A tool they say accurately describes reality from particles to planets to the whole cosmos.
If they're right, even partially, it's a huge shift. It could open up completely new ways of thinking about physics, and potentially, down the line, those radical technologies they mentioned, gravity control, FTL travel,
Yeah.
manipulating space-time itself.
It's definitely an alternative viewpoint, challenging some deeply ingrained assumptions in physics and offering a path, at least in theory, towards engineering reality in ways we usually only see in fiction.
So we've traced this idea from ancient debates about empty space versus an ether.
Through Newton, Maxwell, Einstein's geometry, the weirdness of the quantum vacuum,
Arriving at this proposal, electrogravimagnetics.
which suggests we view space-time not just as curved geometry, but as this active, refractive stuff shaped by electromagnetism. EGM is presented as a way to quantify that.
A potential new lens, they argue, for understanding physics at all scales. And maybe, just maybe, unlocking some revolutionary applications.
Which leaves us with a pretty profound thought to chew on. If space isn't empty, if it's this dynamic, energetic thing interacting with matter electromagnetically, what does that really say about the fundamental nature of reality?
And following the source's logic, if we can understand and perhaps manipulate this interaction between matter, energy, and space, what are the true limits of the possible?
Yeah.
What new questions does this whole EGM framework spark for you about how everything is connected?
Definitely something to think about.
Thank you for joining us on this deep dive into quinta essentia and the provocative ideas of electrogravimagnetics.